Hi everyone, I'm so excited. Welcome to week 3 of Stella Bootcamp, which is powered by Hadao and Stella East Africa Community. So, Hadao has an initiative where we'll be doing monthly bootcamps, and this month we are focusing on Stella. Why Stella? You can write smart contracts in Stella and you can be able to deploy those contracts. And Stella also has grants for builders where if you're building real world applications, you need to check them out. So after this um, DevCamp, we're hoping to have all of you join their open source contributions and grow your skills. And hopefully, we want to see those projects coming out. So with me is Ayomide, who is our tutor, and he's going to tell us about what this week is about and dive into it. Welcome.
Yeah, thank you so much, IJ. So, hi everyone, and I'm happy to have everyone here on seats. And we'll literally just proceed from where we stop. But we have the usual ritual of having someone to, give us like an overview of what we have discussed from last class. So, who is volunteering to do that? Mark? Mark? Okay, yeah. Let's hear from Mark.
Hello.
Hi, Mark.
Hello. This is very awkward to admit, but this is the first time I've joined the bootcamp classes because this whole time I was attending the dev classes and thought that was part of the bootcamp sessions, but I've had that cleared out, so I've been working on catching up, which I am going to do that in the next 2 days. That's my time box. But I thought I'll just join in today and see if I'm able to pick up whatever that's already going on. My apologies.
No, no, no. That's great. That's great. That's great. I love you have a timeline to catch up. That's great. Thank you so much, Mark. Well done. Thank you.
Thank
I'm
you.
happy to
Thank
have you
you.
join us today. Yeah. What of Johnny? Do you want to talk about what we have discussed from last class? Johnny?
Hi, how are
Hi,
you?
I'm all right. Was Johnny dropped? Okay, okay. You can unmute, please, Johnny. More like an overview of what we discussed from previous class, please. So we can move on right to what we have today. I just want to ensure that we all are up to date with what we are learning. I think Jani is still muted. So we don't take, okay,
Okay, okay.
yeah. So we don't take much of our time. Let's listen to Stephanie.
Oh, sorry, Jenny. I mistakenly muted her, so she can just go again. Sorry.
Oh, so you can unmute, please, Jani. Can Jani hear me?
Sorry, I don't understand you.
Okay. I was like, can you give us an overview of what we discussed from last week lectures?
I need the chat, please, because I don't understand your question.
Okay,
He's
okay.
asking if you can do a recap of what happened last week.
Oh yeah, yeah. I saw watched the videos in YouTube.
Yeah. So what are the things you enjoyed from the videos you watched in YouTube?
Okay, yeah, yeah.
Okay, so we don't take much of our time. Stephanie, can you unmute and speak, please?
Good afternoon, everyone.
Good afternoon.
So in our last class, we spoke about serialization, and we said that serialization uses a 64-bit format and it's stored in a compact way. Then we spoke about contract lifecycle in Soroban, which we have four. We have the development. This stage is where we write the code, compile it into a wasm bytecode, and then test the code. Then we have the deployment. So after the code is being compiled, the wasm bytecode is uploaded to the Stellar network. Then I think we store the file that is being uploaded in a contract data ledger, and then we have a unique hash that we use to identify it, a unique hash that we use to identify it. Then we have the test step, which is the execution. Execution is the interaction with the smart contract. Then we have the last step, is the termination. This is where we no longer need the contract, so it will be terminated. Then we talked about tools for contract development. We have the Soroban SDK for this SDK is used by developers to help their process faster. Then we have the Soroban CLI, which helps us to interact with the contract, invoking and inspecting the storage. Then we have the Soroban local net and we have the Soroban IDE. Then you also spoke about gas fee, and from what I learned that gas fee helps to prevent spamming, and I think that's all. That's all from my side.
Great, 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 great. I could say that is excellent, as that literally what we discussed from previous class. Thank you so much, Stephanie. So, without wasting much of our time, I would share my screen and we dive straight into what we have for today's class. So, for today's class, we will be using the official Stellar documentation, as I will not be sharing any slides from today's class. I just hope every one of us have access to these previous slides that I used for last class. Well, for today, we will be starting from setting up our Soroban CLI, Stellar CLI, and doing this would help us literally build and deploy our first Soroban smart contract. Now, why I don't have a slide for this is because I do not want you to copy any command from any slide. Like I've always encouraged while I was even teaching Rust, it's important that you always refer to the official documentation for whatever command you are taking in to install any dependency or anything in your computer. As you know, there are a whole lot of, malicious content out there. So that's exactly why I'll be using the Stellar official documentation to pioneer today's class. So what are the things we are going to be talking about from today's class? From today's class, we'll be setting up our environment that includes downloading and installing the Stellar CLI. And for those that could not join our Rust class, they would also have the opportunity to see how to install Rust on their local machine. And then from there, they download and install the Stellar CLI. From there, we would initiate a new project, and the new project would analyze what the Stellar contract code looks like, and then we would definitely then see the difference between it and Solidity. Next up, we are also going to deploy the contract, also look at testing a contract, and then next, we will then interact with the contract that we have deployed. So starting up, so we made mention that the Stellar smart contract are programs written in Rust. So definitely you need the Rust environment. You need the Rust toolchain. And so to do that, I'm going to literally copy this and paste this in the chat for everyone to have access to this official documentation. I don't think I can paste it for everyone. Okay, I'll just paste it to the host and the host can share it. So I'll just paste that there. So everyone, you download the Rust by copying. For those using either a Mac OS or a Linux operating system, you just have to copy this command and open your terminal and install it. But for those using Windows, all you have to do is you have to download it and run the executable file that you get, basically. Then after doing that, okay. So after doing that, the next thing you're basically going to do is you are going to install your target file. That's your WASM32 unknown target file. And after installing that, you basically have access to your Rust tool. Then the next thing we want to use is an editor. We've obviously been using an editor even when we were writing Rust. And then for the editor, we have been using Visual Studio, and instead of the editor, we have been using Rust Analyzer to help us analyze our code so we can see even a compiler error before it gets to the runtime error. Also, after doing that, we will then install the Stellar CLI. Now, the thing about Stellar is that there's always improvement. What do I mean by improvement? You see, about some week back, I was trying to, work on a Soroban smart contract. And I tried compiling the code, but I could not compile it. Why? Because I was using an old CLI tool. So an old version of the CLI, of the Stellar CLI. So what did I have to do? I had to reinstall what? The CLI. So to do that, you can, for those using Mac OS or Linux, you can either use Brew or you can use Cargo. Now, for those using Windows, you need to download it from the latest release. Then after you've downloaded it from here, let me open it here. Now, this is what it's going to look like. It's going to be an executable file. So after you've downloaded this executable file, for those using Windows, after you've downloaded the executable file, you would then install it. You run it and install it. And then after installing it, you have the Stellar CLI. So after you've installed the Stellar CLI, there are certain things you have to do. Now, the auto-completion is optional. If you like, you can do it. If you like, you don't do it. The auto-completion is just that in your shell, when you're trying to write a command, it literally helps you complete it automatically. So you can use this command, as you can see, for if you are using batch in your shell, you use this command, you copy this command in your terminal and paste it. If you are using Zich, you use this. If you are using Fish or PowerShell, any one you are using, you just you copy it and you paste it. The next thing you are going to do is you are going to configure your CLI for testnet. Now, remember that while we were talking about Stellar, we mentioned that we have the Stellar FutureNet, the Stellar TestNet, and the Stellar what? Mainnet. Now, for all we'll be doing, we'll be focusing on only the Stellar TestNet. And so to focus on the Stellar TestNet, it means that we have to do what? We have to configure our network. So to configure our network, we would definitely need an account for us to deploy, interact, and do every sort of thing with our smart contract. So to do that, you generate your key. And now you use this command to generate your key. And then after you've generated it, you would name your key. For this one, this person named the key Alice. And then the network is what? The test net. And then this dash funds means you asked it to what? To fund the account. So now the next thing you can do is to, use Stellar keys address, and then you can basically see the address that has been generated for the account. And that's basically how you would set up your what? your environment. So after setting up your environment, the next thing we want to do is now to initiate a new instance. Now, if we want to initiate a new instance, remember let me increase this. For Rust, oh no. Okay, remember for Rust, if you want to initiate a new instance, all you do is cargo init and then cargo init and then the name of the instance. But for Stella, it is different. It is Stella contract init and then the name of the contract. Now, in this case, the name of our contract, let's just name it Hello World. Now, notice that it has initialized a new contract named what? Hello World. So this Hello World and oh, I named it Hello World. So let's go into it. I'll paste this. And then now we are into the folder. So let's see what's inside the folder. We have contracts, we have readme.md, and then we have cargo.soml. So these are the things we have inside of it. So I'm going to open it in a VS Code terminal, and here we have it. So this is basically, I've increased it. This is basically what you would find when you initialize or create a new instance of a Stellar contract, of a Soroban contract. And so inside of it, you would have a library, that's lib.rs file. You would have a test file. Then you would have your cargo.toml where you can add your dependencies. And then you have this make file. This make file literally is a file that shows you how to run the commands and all of that. You understand? Whether you want to build, you want to test, you want to, you want to format, all of the commands is here, basically. And then you have your targets. Now, remember when I was saying it in class that when the first thing you want to do is to write your smart contract. Now, let's assume that we have written this smart contract. I mean, we did not write it, but we are going to assume that we have written this smart contract. So after writing this smart contract like this, the next thing we want to do is we want to compile it. So to compile it, what are we going to do? We are going to use Stellar contract build. So this is literally going to build the contract, as we can see. It's going to build it and compile it. And then inside of this target folder, remember that we said our contracts, we don't literally push our contract to Stellar. Rather, what we push is basically our WASM bytecode. And we are going to illustrate all of what we have been talking about in the slide at this example, using this example. So our contract is literally still building. Our contract is literally oh, it's done building. So can we see after it has compiled and built, everything, the WASM should be inside of this release. And then we could see build. Okay, this is a build. Let's open the WASM. Yeah. And then here it is. So can we see our hello world.wasm? Obviously, we cannot view it. I don't have what. In fact, it is more like a binary distance, so you cannot even view it. If I click on open anyways, this is what it would look like. We cannot really view it like that. You can't view it like that. But literally, this is actually what is being sent and deployed to the Stellar what? To the Stellar ledger. Now, that is talking about the WASM bytecode, because when I was talking about compiling and all of that, someone was like asking, how do you compile? How do you do? That is how to compile. And just like that, we already have our WASM code. So So the Stellar CLI is literally what allows us to compile. It's what gives us the opportunity to compile our smart contracts. But let's deep dive into the smart contract itself and see what the smart contract is all about. So I'm going to close this and then we talk about the smart contract. So the first thing we want to see here is that we have a procedural macro here, and this macro is literally saying no STD. What does no STD means? No STD is literally signifying that for this contract, we are not interacting with the Rust standard library. And if you can remember from our slide, I mentioned that every single thing, whether it's a vector, whether it's a string, every single thing would be coming from the Soroban SDK. Nothing would be used from the Rust standard library. So everything we are using here would be coming from the Soroban SDK. So what are those things that are coming from the Soroban SDK that we'll be using? Can we see it? Now, we imported the contract. It's actually a macro. We imported the contract implement. It's actually also a macro. Then we imported the vec, the environmental variable. If you can remember ENV, we explained what ENV was and what is contained inside of ENV. It was the environmental variable, where we have the what? The host. Then next we imported the string and vec. Now notice that what we are just trying to analyze from this contract is the default contract that comes when you initialize or create an instance of the Soroban smart contract. So the instance of this contract is what we can see, and that's what we are trying to analyze. Now the first one is a particular struct called contract. Now, this contract is the name of the contract itself. Now, this contract is a single struct. So that is, it doesn't have any field elements. Now, if you can remember when we were talking about struct and we were talking about different types of struct, where we said there are some structs that don't even have any field element. This is an example of it for this struct. So this particular struct signifies that it's a contract and it's literally serving as a contract name. And then this macro on it signifies that, okay, this struct is the contract what is the main struct for the contract, because as time goes on, we will later see that we can keep creating more structs based on what we want to do. We can create, let's name it students, and then we create more things inside of it. And inside of all of these things, every single one of it would have what we would use to differentiate it. And to differentiate this, we'll basically be using what? We'll be using, let me remove populate. Is there something I did not add? Struct. Oh, this should not be here. But let's leave that for now. We get back to it. So this is literally what would differentiate the main struct for the contract to what? To the remaining struct that could act as a data structure for what we'll be implementing. Now, the next step to do is to implement that contract. Now, implementing this struct means we are implementing the contract, and inside of this implement contract is where we have all the functionalities of the contract. So let's say we are adding more functions to the contract. Every single one of the functions will be implemented inside of what? Inside of this contract implement. So this, we could change this to change as the name of the contract, and then if we have to implement what? This particular struct. And so it signifies that this is the what? This is the contract. And then all the methods inside of it would basically be what? The methods and functions that you can call from the smart contract. What is the first method or the only method that came with it? We have hello. So what does this method does? It only prints hello. It's a function hello, and it has the env, and then it has the 2, and then it has what? It returns a vector of string. And we use this vector macro, and then we printed hello. And so we can deploy this. This is just printing a vector of a string. And so we can literally what? We can deploy this and we can call it, and basically we have access to what? To interacting with the contract as a basic minimal contract. Notice that from this contract, we are not storing anything in the contract. In fact, all that is happening is in Solidity, you can call this a pure function. A function that is not really interacting with the storage. It's only what? It's only have the variable and everything is returning inside of the what? Inside of memory, because it is inside the function. And that's what this particular function too looks like. Now, at this particular point, before we proceed to the looking at what is inside of the test, does anyone have any question? Does anyone have any question?
It's okay.
I didn't hear you clearly.
I am installing all the dependencies.
Were you able to install it?
Now I am installing.
Miss anything from the class? So any other person have any question based on what we have discussed up to this point? Questions?
That's Mr. Ayo. Would you
Yeah.
care to specify or just remind me again, how is the hello function a pure function in this case?
Oh, let me ask you, Mark, are you coming from the EVM background?
No, actually, this is the first time working on anything blockchain related.
Oh, wow. So how strong are you when it comes to the knowledge of blockchain?
I'm still grasping everything. I'm still grasping everything, and yeah, it's not very strong at the moment.
Okay.
Yes.
Okay. No problem. So what I'm going to do is I'm going to show you what a storage looks like. And
Okay.
understanding what storage looks like, I don't know if I should implement it now or I should implement it when we start implementing our smart contracts. But up to this point, do you understand everything we have discussed up to this point?
Yes, I am picking things up, and I'm hoping to connect everything as we move along. But so far, I just need to get the context of like how this pure function comes into play.
Okay. Now look at
Yes.
this function. It's an hello world function, and we are passing in the host, which is coming from this environment, and we are also passing in the tool, which is more like the person we are trying to greet. It's just an ordinary function that is not storing anything in the storage of the smart contract. Notice that we don't even have any data key leading to the storage of the smart contract. And so what we are doing here is now returning a vector of string. And so vector of string is going to include what? It's going to include the hello and the what? And the person we are what? We are telling hello. So what if we wanted to, let me add to do macro here. This to do macro will help us. Oh, remember, we don't have access. Okay, yeah. The to do macro is fine. The to do macro is just a macro that helps us remove, compiler errors to ensure that, okay, we are trying to return a vector string here and we have to return it. This could either be this, if I remove this, or it could be, you could remove the return and this, but I would just want to add more functionalities. So you're going to see what I'm trying to do. So let's say we want to store something in the storage, then that would mean we have to have access to the storage. How do we have access to the storage? We have access to the storage through this env. So we're going to say env dot what? Dot storage. Dot storage. So we say dot storage, then we say dot what? Dot instance. Then we say dot what? Dot set. So we have different things. We have get, we have set, we have remove, we have as. So we're going to say dot set, and then we have a key and a value of what we want to set. In our case, we could create more like a key. So we could create, let me think of a key we can basically create. So let's just use a simple symbol to create the key. No, let's create something here, and let's say, what's our key? Let's say let our key const key. Let's name it key. Equals. We're going to use symbol. So we are going to use symbol basically for it. So let's just make this capital letter. Bam bam bam. Okay, since is a, why is this changing to small letter? So we're making it a key. We're going to make use of symbol, which we are going to also import. And then we're going to use the symbol short, and we are going to add the name of the key. Let's name this key storage key. Let's name it storage key. Okay, and then we're going to do this. So let's remove this. So we're going to import this, definitely. So you come here, import this. Then you come here, you import this. And then we are fine. Why is this? Okay, it's greater than what we meant to give it here. Let's just use storage. Let's just use storage. Why do we have this? Okay, let's leave it like this. Okay, so we are good to go. So yeah, we can have this as key. And then what are we storing as the value? We can have, why is this? Okay, yeah, it has to be borrowed. And then we can have our value. What should we store as our value? Let's say we are setting it as 32. Basically. Let's do this. And so, yeah. So this is an example of how to set to storage. Can you see? This is an example of how to set to storage. You have a key, and then you have what? The value you are setting to storage, basically. So this is how to do it. Now, if you want to get, it's still the same thing. You just do get, and you remove this, since you just have put your key to what you are trying to get. You get. And then you basically have to, put the data type of what you're trying to get and all of that.
Okay.
And you are able to do that. So that's just basically everything that has to do with storage. Now, this is just an example to show you how you can store, but all we are trying to do for now is just to talk of how to deploy your smart contract and how to instantiate. We are definitely going to create a project. In fact, we are going to create a project where we're going to name it library. It's going to be a project where we have a library and we can store different things like books. We can store books in the library. We can get a book from the library. We can see if there's a particular book in the library. We can see if we can see all the books in the library. So we are going to start by implementing that contract, a library contract. We are going to do that. And then we are going to doing that to show us how the fundamentals of a smart contract. Because if you are building any smart contract, you want to understand that there are certain fundamentals to it. What are these fundamentals to your smart contract? First of all, you want to understand how to store and how to get, because that's majorly the first thing. Once you understand how to store in your smart contracts, then you need to understand how to get from your smart contract. That's to retrieve the data you've stored in your smart contract. Then once you understand that, the next thing you want to do is to understand the data structures. How can you implement different data structures for what you are storing? Now, remember, whatever you are storing is based on the data structure you are going to use. So you want to use it, create an example contract like a library contract. You know that, okay, in the library, I want a structure. I want to have the names of the book, the ID of the book. I want to have a vector that can keep list of all of these books. So you have to also think of what the structure for what the data would look like for your smart contract. Now, what I'm just saying now is more like the fundamental to smart contract. Whether you're writing a Solidity smart contract, you're writing a Cairo smart contract, you're writing Ink smart contracts, Soroban smart contract, or you're writing Coswasm, anything you're trying to write as a smart contract, you have to understand how to store and how to retrieve. Then the next thing is understanding the data structure you are using for the data you are storing in your smart contract. Then the next thing obviously would then be understanding the business logic of your smart contract. Okay, I want to create a contract for library. Okay, how do I implement the function that will retrieve these books? Okay, what are the functionalities I want to have in the contract? Should I be able to, implement something that will allow to borrow? And if I'm borrowing, how many times can a person borrow from the library? So this is the business logic of your code. So like I made mention of 4 different things: understanding how to store and get, understanding the data structure, understanding the business logic, and understanding how to put all of this together literally. And then after you've understood all of these fundamentals, then it's easy for you to learn how to deploy your smart contract, how to interact with your smart contract, basically. So is that gotten? Does anyone have any question based on what we have just explained now? Oh, someone said I should send the code in the chat. Now, that code I'm explaining is just a code that comes when you create the instance, a smart contract instance. So when you create your smart contract instance, you have this code generated for you. So the next thing now, when we want to now create our own contract, all we have to do is now we should use this structure that has been given to us. And then using this structure, we would basically what? We'll basically create our own new smart contract. Now, what's the benefit of us having this structure created down for us by Stella? One of the beautiful things is that it allows us to build and expand our smart contracts. Now, in Rust, there's something called workspace. Workspace is a way you organize your files and your code in Rust, where you are able to enlarge and create different Rust files that can interact with each other. So if you notice this particular Soroban contract, the instance actually came in that form. How do we know? Look at inside of this. You have now inside of this folder, you have your contract. Inside of your contract, you have a folder named Hello World. Now, inside of this Hello World is where you now have your source file, your library, and your tests. Now, if you go, you also have your cargo here. Now, if you go down to the outer layer, you have your cargo file here. Now, your cargo file, from what you can see here, you have what we call what? A workspace. Now, inside of this workspace, it lists every single thing you have in what? In your smart contract. So your contract, under this contract here, all the new folders you are creating, probably you are creating a very huge smart contract and you are having about 5-10 folders with about 5 files inside of these folders each. You can basically organize it with this workspace pattern that is basically used in Rust. And so Soroban made it easy for us by already implementing it down for us. So you don't have to create a new workspace when you are trying to, work with your smart contract. So the next thing we are going to talk about now is testing. Now, in this smart contract, what we want to test is we want to test if we call this method hello, we should be able to get the env, the string hello, and the tool, that's the address we are passing in here, which we would call, it could be anything. You could pass in anything here as the parameter here. So this is what the test look like. So to create a test in Rust, you basically have to use this CFG, and then you have this macro test on each of the functions you are creating. So let's say I want to create another test. I need to, at the same time, still write what? Tests on top of it, and then I would what? Create test. Let's name this one test 2. What's the essence of this? This is to make Rust understand that this particular function is not a function used for something else other than a test. It's to help Rust compiler understand that this is a test function. So if you write a function and you do not add the test macro on top of it, the problem you would have is that it's not going to run that function as a test. How do we know that? Let me comment out this test, and then to cargo run your test, to run your test, you have to do cargo test. And so it's going to compile, and then it's going to run the test. Now notice what happens. Let's wait a little for it to finish running the test. And after it has run the test, we are going to look for it. Okay, great. Now notice that it ran this test. Forget the fact that it took a while to run the code. The next time I run cargo test, now it would not take as much time as it has been built already now. Can we see? So notice that it says running one test, and it says, okay, the test passed. Now, if the test failed, it would have said failed, or if it's ignored, you could have, there's another macro you can use for ignoring tests. So for what we did here, notice that it did not include this particular function. Why? Because this particular function did not have the what? The test macro. So if I include this test macro here and run this, it's going to return what? 2 tests. Can you see? Running 2 tests. 2 tests passed. Although nothing is inside of here as there's no obstruction, then it basically says the test passed. Now let's remove this and then talk about what is inside the test. Now, while we were talking about the env, we spoke about the host. Now, the host gives us access to something, the contract client. Now, the contract client is basically what we'll be using in this CLI environment to interact with what? With the contract. So, how do you initialize a new instance? So to initialize a new environment, you create a variable and then you say env default. Now, you then create env and you do dot register. Now, when you do dot register, it automatically gets this particular contract. This contract is the struct coming from your smart contract. Yeah, this one. So if you named it something else, whatever you named it there is what you pass in here. Now, when you are creating your smart contract could have constructors to initialize the contract. Now, if your contract have initializers or a constructor, here is where you will pass the constructor argument. Now, if we go down to this register, you can see that it has the contract and then what? The constructor argument. Then it returns what? An address. So this particular one would then what? Return an address, as we can see. So after it returns an address, you then create the client. The client is basically what you would use to interact with this instance of this contract. So you're going to say contract client, and then you create a new one, you pass in the address and you pass in the env into it, And then after passing it in, you have access to what? To the method. Now notice that if this contract was named something else, probably LO, you name this LO, notice that what you should have here in the test should also be what? It should also be LO LO client. So this should be also what? LO client. This should also be what? LO, basically. Can you see? So whatever your contract name is what you should pass in as the type that is what? That is going into what? Into this new or this what? Or this contract ID, basically. And then after creating the client, you then have access to the method. The method we are calling here is LO. So here's the method LO that we created here. This one, this LO, not this LO. This LO is what I named the contract. So we could have just named it LO world. But we know we have to change it for the what? For the test too. So we have to change this to what? LO world and LO clients here, LO world clients here. And then we are good to go. So after doing that, we have access to our LO function, and instead of our LO, notice what are we passing inside of it? We are passing our env and what? And string. But notice that the env, we've already used it here. Yeah, we passed it in here, and so the env has already been passed here, and so the env is what created our client for us. So when we call it, all we need to do is to pass in what? The to. Now, passing in the to, it's a string. And so we are going to pass in the string. And here is what the string is, dev. So technically, what this method is going to show to us is what? Hello what? Hello to, which is what? Hello dev, right? So that is basically what we have here. So it's a vector of hello and what? And dev. So if we store this, we should have a vector of string, as we can see. And then this assert equal is basically used to assert that this particular word that we So we stored it inside of this variable word, and then we are asserting whether the word is the same thing as what? As the vector. So we just basically created a vector, passed in the env, passed in the string hello, and passed in the dev. So we are expecting this. So we want to be sure that what is happening here in this function is what we are actually expecting. So we are certain that this is equal to this. So it's a vector of the env, the hello, and the dev. So when we run it, it happens as what? As true. So it runs test and it says the test passes. But what happens if we change this one to developer? Is our test going to pass or fail? Our test is basically going to what? Fail. Why is our test failing? Because what we passed in here was what? Was dev when we were passing it in the what? In the function here. We are passing in dev here as a string. And now we are testing it with hello developer. So it's going to fail. So if we change this back to dev and we run our test, then we are what? We are good to go. So at this point, does anyone have any question? Any question? Any question? Okay. If there are no questions, we would proceed. So now we have looked at what a typical Soroban smart contract looks like. We have seen it and we have seen the overview here. Then we've also seen the tests for a Soroban smart contract. We have also discussed the importance of understanding how a data is stored and gotten from the smart contract, although we've not implemented it in an elaborate way, but we've understood that it's important for anybody that is trying to create a smart contract to what? To understand how to what? To retrieve and how to, how to set a data in the smart contract. And then the next is understanding how the business logic works or happens for whatever implementation you are trying to create. We've also discussed the data structure you want to use for your storage. So all of these are very important. The next thing we'll be talking about now is the deployment. How does deployment works in Stella? So let's go back to our official documentation, and then I would show you. Now, notice, let's go back to this setup down here. Notice that after you create your account that has funding, you have opportunity to actually look at the account by calling this command, Stellar keys address, and then the name of whatever you store the account as. So let's try to do that. Let's try to paste Alice here and then paste it. Can you see? Here is my my address for this Alice. But I'm very sure this address would definitely not work anymore. And that's because when I created this address, it was a very long while ago. It was a very long while ago, and the Stellar testnet probably have what? Have erased it because there's obviously new development and all of that. Can you see? I searched for it, but I could not get it. I searched for it. Now, I'm going to check out for a new one I created, and I named that one Ayomide. So here it is. I'm going to copy it, and I'm going to paste it here, and then we can see. Here's the one for Ayomide, and can we see the account? Here's the account. Here's my balance. Here's my balance. It's meant to be 10,000, but because I have done some interaction, I've deployed, I've interacted with the test net. I noticed that I'm on the test net network. So I have about 10,000 test lumens, but I've used out of it for deployment and all of that. So here it is. Yeah, some of the transactions I've done on the what? On the account, basically. So this account is what we are going to use to interact with the testnet. I think there's a question. No, there's no limit. There's no limit. You can basically create. It's free. Remember, it is a test net. It's a place for you to experiment. So it's free. It's free. Okay. Okay, great. So that is my account, Ayomide, on Stellar. And so what I want to do next is to deploy this contract. Now, how do you deploy? If you go to the official documentation under deployment, you see the instructions to deploy. All you have to do is what? Stellar contract deploy, and then you target the WASM. This is the WASM you are trying to what? You are trying to deploy. Did you get that? So this is the WASM you are trying to deploy, and then the source is the address, the account you are trying to use to what? To deploy. And then you choose the network. In our case, it's testnet because we are working with testnet. And then hello world is the what? Is the contract. What we are identifying the contract as, we are naming it for this instance, we are using what? Hello world. So without having to type all of this, I'll just copy this to my terminal here. Now, once I copy it to my terminal, I'm going to show us some things. This thing is not going to work, and I'm going to tell us why. So it's trying to deploy. Can you see? It says account not found. We tried looking for this my Alice account on what? On the Stellar scan, but we could not find it. And so that's because the account is old and it has been wiped out of the testnet. So I had to create a new one, which is what? This Ayomide. So I'm going to use this Ayomide account. I'm going to change this from Alice to Ayomide. So let's name it Ayomide. And then I'm going to deploy. So what are the parameters we have here? We have the Stellar contract deploy. Then we have the WASM. What is the WASM? Remember, I made mention that the WASM is what? The WASM is what we are deploying to the Stellar chain. And how do we know? This is it. Under target, we have WASM 32 unknown release hello world what dot WASM. Now, if you come to target, it says what? Under WASM, this, then what? Under release, we have what? Hello world dot WASM. This is what we are trying to push. So this code is not what we are pushing. This is what we are trying to push. The WASM what? The WASM bytecode. Okay, are there questions? Are there questions?
Yeah, I'm asking,
Okay.
you know,
What are you asking?
I've coded with Solidity before,
Okay.
and the concept called private keys.
What?
Private keys.
Sorry, I didn't hear what you said.
I'm asking
Okay.
if anywhere in the Soroban we are using private keys.
Yes, we are using private keys. Yes. Now remember, whenever I mention account, what is an account? An account is made up of private key and your address, right? Now, we created an account here. Now, when I was talking about setting up your contract, I came here and I said, this is how to create an account. You use Stellar Keys Generate Global, and then you name the account, the network, and then you ask it to fund. You're asking it to fund because you want to use the funded XLM for your interaction. So this account it is generating includes both the private key and the public address. But if we say Stellar Keys address, we are only trying to get what? We are only trying to get the Stellar address, not what? Not the private key. You get? But what is allowing us to interact with the contract is what? Is the private key. So what will allow us to deploy this is what? Is the private key. Did you get that?
Yeah.
Okay, great. So the next thing we want to do now is to run this command. And for the command, we have targeted the WASM we are trying to push. The source account is Ayomide. The network is testnet, and the name of the contract is Hello World. So I'm going to run this, and then we're going to see. So can we see? Skipping install because WASM already installed, and it's using the WASM hash this. So this WASM hash is literally the WASM hash I always talk about, the unique identifier for your contract. So this unique identifier is what you know that as your contract executables. The implementations in your contract is from this WASM hash. Now, after this WASM hash has been deployed, then it uses this WASM hash to initialize your own contract. And this is now what? An instance of the what? Of the new contract. So how do we know? Let's open this. And then we have access to it. So this is a new contract that has been deployed. And if we look at it, we can copy this contract address and we come here, search for it. We see that it's literally the same thing. So this is the contract and yeah. So can we see 025, 03, 17, that's today's date. Can we see it was deployed now? So we just deployed it. This is the deployment date, as we can see. Now we can now start what? Interacting with this contract. So our class for tomorrow, yeah, but this is where we'll be ending our class for today. I am sorry we've spent more than the time we are meant to use for our class, but I really wanted us to stop at the deployment of the contract. So tomorrow we are going to interact with this contract. We are going to call the hello function inside of this contract. And then we are also going to We are also going to start implementing a new contract called library, and that is what we'll be working on tomorrow. So I'll stop sharing now, and I would hand over to IJ. Are there any questions at this point? Okay, if there are no questions, then I'll basically hand over to IJ. Thank you, everyone.
Thank you so much, Ayomide. Thank you so much, everyone, for joining the session. And hopefully tomorrow I'll see you and more of you. So that's a wrap for us. See you guys tomorrow. I will put the video recording